All right, so we're just going to start the notes and we'll see if my voice can hold out for the whole thing. But we're talking about proportions and equal ratios, so it's kind of building on the last section where we looked at a ratio of guys to girls in the room would maybe be, 2 to 3 or something like that. And for this, we're starting with Roman numeral 1, equal ratios. So how do you tell if two things are equal? And as we go through the chapter, we're actually going to get probably 3 or more different ways to do this. So it's kind of, some will be better in some cases than others, but a lot of it is just what's your personal preference. So first thing, equal ratios. If we have something that's the equal ratio, it really just means they have the same value. And we talked about how you could write ratios as a fraction. And if you would punch them into your calculator and see what they equal as a decimal, that's one way that you could determine are they equal, but I'm getting ahead of myself. So equal ratios. So let's say we're to have like 1/2, and agree 1/2 is a ratio. So 1 out of every 2 teachers has their voice today or something. But okay, 1/2. If I were to multiply that by 1, do you agree I get 1/2? I don't change its value any. And I don't know if that's even worth writing, but I'm just trying to really prove the point of this here. If you were to take 1/2 again, kind of just below that, if I multiply that by 4 over 4, 4 over 4 just equals 1, right? So I'm going to do like a little double arrow, do it, don't do it, but really those are just the same thing. 4 over 4 is the same as multiplying by 1 when you multiply by 4 over 4. But now I get a 1 times 4 in the numerator, so a 4, and a 2 times 4 in the denominator, I get an 8. So what I'm really trying to say then is if 1/2 times 1 is still 1/2, 1/2 times 4 over 4 is 4 over 8, but 4 over 8 is really just 1/2, because essentially we multiplied by 1, we didn't change it any. So you could say 1/2 and 4/8, those two things there, they're just equal ratios. So equal ratios. If I were to take my 4 over 8 and divide that by 4 over 4, that'd get me back to 1/2, agreed? So multiplying by 4 over 4, dividing by 4 over 4 is the same as just multiplying by 1. And that'd be true for any number over itself. So you could take and multiply both of them by 5 over 5, or 12 over 12, or 6.5 over 6.5. But it's going to work for multiplication or division. We good? Cool. And the book likes giving ones like this, and I really think these are kind of fun, but I'm a math teacher. I like doing math. But they say, given a ratio of 9/12, or maybe just say, we'll say fill in the table with equal ratios. And at the beginning, you might get a data table that doesn't really have much filled in, but later on you're going to get ones that have like 3, 9, so it's going to be 2 rows, and I have 2 rows and 5 columns. So my top row I have 3, 9, 18, and then like 2 blank parts. My bottom row below the 9 I have a 12, and my last 2 blanks in the bottom are 48 and 2. So I try to make a data table that looks like that a minute. And they're saying we want to fill this in with all ratios that are equal. And really they're saying this here is going to be that ratio 9 over 12. So that's kind of what we're starting with. We have this ratio 9 over 12. And we're trying to figure out a whole bunch of ratios that are equal to 9 over 12. And I would look at it this way. If you're going to take and jump from 9 to 3, how do I change 9 into 3? What math operation? Multiply or divide? So here we're dividing by 3, right? So to get the number that goes below the 3, I have to divide by 3 also. So 12 divided by 3 is 4. So 3/4 would be another equal ratio. What number would go under the 18? Go for it.
24.
24. And he got 24 by looking at 9 and saying to go from 9 to 18, you'd have to... Yep, so here you multiply by 2. So then you'd have to do the same thing down below. Multiply by 2. Now we need to find the numerator part. So how would you figure out what goes up above 48? So, yeah, Nolan?
See how many times you need to do 12 to get to 48.
Perfect.
To the 9.
Yep. So 12 times what gets me? Oh, you could go. So you're saying 12 to 48. Is that what you were doing?
Yeah.
Okay, and you could do that. You could say that that's going to be times 4. And 9 times 4 then gives us 36. Anybody do that a different way? So, somebody else? Go for it.
24 times what equals 48?
Exactly. So you could say 24 times 2 is 48. So then you could say 18 times 2 is 36. And at that point, it's really just a matter of personal preference. You could have even started over here with the 4. 4 times 12 gets you 48. So then you do 3 times 12. So you kind of pick what works for you. And the last one, up above my 2, what has to go up above my 2? Go for it. It's a decimal.
Yeah, I knew that. Is it 0.5?
Close. You have all those denominator, all those bottom numbers. Which one's the easiest one to change into 2, probably? Yeah, 4 divided by what gives you 2? 2. So we know going from here to here, you divide by 2. So you have to take the 3 and divide by 2. So you get the 1.5. Does that seem to make sense? Is that kind of fun in a way?
Yeah.
Okay, I'm glad people said yes. But
Not fun.
it's not fun. It's more fun than a root canal. I've never had a root canal, but I figure they're probably not fun. Okay. Unless maybe you like the happy gas or something. Okay, moving on, proportions. So proportions are going to kind of be related to that. A proportion is really just one ratio that equals another ratio. Or the way the book defines it is they say proportions, they say two ratios are equal. So proportions say two ratios are equal. And yesterday we looked at like 3 different ways to write ratios. Now we're going to be sticking mostly with that fraction way. So an example of a proportion, you could say it would be something like this. So 1/3, that's going to be equal to, somebody give me something that could be equal to. 2/6, that would work. So that's officially a proportion. We have one ratio that equals another ratio. Those are exactly the same. In my notes I had 1/3 equals 3/9. That would be another proportion. You could do different things. Good? So you could test if something's proportional. So say the book gives you something like this, 1/3 equals 2/6, and you're trying to figure out, well, is that a proportion? Are the two ratios actually equal like they say they are? And there's a couple ways to do that. So I'm going to switch colors and say you could check, or you could test if something is a proportion by, I'm going to do a little colon. I think we get 2 of them in today's notes, but then we'll get more later on. I'm going to say, so check like, and I'm going to just do a Roman numeral 1. So check like what we did in Roman numeral 1. And in other words, if we had what we just had before, we had 1/3 equals 2/6. So say they gave that to you. Sometimes the book will put like a little question mark up above the equals, like, are these equal? Then what you could do is you could just look at it and say, well, 1 times what gets me 2?
2.
Yep, so here you have to multiply by 2. If I do 3 times 2, does that give me 6?
No.
Yep. So essentially you're saying 1/3 times 2/2 equals 2/6. So then you know that they're equal, because you have that same multiplier in both of them. You're multiplying by 2/2. How are we doing on that one? So that's one way. That works nicely if there's a nice multiplier. If instead you're going from like 1/3, is that equal to 15/43? To go from like 3 to 43 is tough. I guess you could look at 1 to 15 is times 15, so then 3 times 15 should be 44. I probably lost you, right? But okay, maybe, okay. What do we do? Said 1/3, is that, you could, I wouldn't write this, but you could if you wanted to. I did like 15/43. And at first I was thinking like, well, from 3 to 43, there's not a good multiplier, so that'd be hard to do. But then I realized in the numerator, you could just multiply by 15. So then in the denominator, you'd have to multiply by 15. Is 3 times 15 43? Nope. So that wasn't an equal proportion. But if you have one where neither the top nor the bottom has a nice multiplier, you could always use your calculator, but it might be nicer just to do this second way. So my second way, so I'm going to do it like an OR, and then here's number 2. This one's pretty slick. If they're equal, So if it's a proportion, the cross products will be equal. You guys familiar with cross products, cross multiplication, that type of thing?
Yeah.
Okay, so if nothing else, maybe at least the words maybe ring a bell. And we'll do this here. So say we have like 3/4 equals 15 over 20. If you were to look at that using that first way, are those two actually equal? Yup, because our multiplier is going to be 5. 3 times 5 is 15, 4 times 5 is 20. But if we didn't know that, or if we want to do this the other way, cross products is saying if we do 3 times 20, so 3 times 20 gives me 60. If these are actually equal, 4 times 15 would also have to give me 60. So you can say, well, 4 times 15, yep, that's 60 also. So because those cross products are equal, then it's a proportion. Another way to maybe write that same thing would be to say, well, is 3 times 20, does that equal 4 times 15? And then you get 60 equals 60, so you know it's equal. So that would be an example of one that would work. I'll quick toss up one that wouldn't work. And so if I were to do 5 over 9, you could welcome to skip this if you want, but equals 25 over 42. Just want to kind of show what happens when it doesn't work. Well, then I do my 5 times 42. We're saying that that should equal 9 times 25. So maybe I could put like the little question mark above my equals. Are those equal? If so, they'd be a proportion. 5 times 42, well, 5 times 40 would be 200, right? 5 times 2 is 10, so this should be 210 if I did that right. So does that equal 9 times 25? Usually when I have 25, I think of quarters, like the money. If you have 9 quarters, how much do you have? Perfect, $2.25. So that ends up being 225. So those two there, they aren't equal, so that's not a proportion. So that second example, if you wrote it down, the 5 over 25, I'm sorry, 5/9 equals 25 over 42, that's not a proportion, they're not equal. Okay, up to now. So we only have one final thing. The final thing is kind of like, what's the practical application? And this is going to be the application I put down, something you could do at Myers, but if you look at the real small writing, they tell you the price per ounce, so they kind of did it for you. But if you had something that says like, which is a better deal? Which is a better deal? We go through a lot of Raisin Bran Crunch in my house. It's the cereal of choice of the males in the Falk house. But if you have like a small box, and not Lucky Charms, Mom ixnays the Lucky Charms. She tries to make us eat healthy. So a small box, I'm going to say it's $3.45. I'll maybe put my dollar sign in there for an 18.2 ounce box. So $3.45 for that. The large box is $3.99, so that one's going to be $3.99. Then you get 24.8 ounces. Living the dream, man. Usually the large ones are a better deal, but sometimes the smaller ones on sale are a better deal. Sometimes the smaller ones on sale still aren't as good as the big box. We've had like a sale where it's like, ooh, so I'll buy a whole bunch, and then you realize after the fact, it's like, I just got ripped off. It's embarrassing. I mean, it's never happened to me because I'm a math teacher, but mere mortals, okay. So which one's a better deal? For this, if you do the $3.45, if you just punch that into a calculator, this here is going to equal 0.19. So in other words, what that's telling us is it's $0.19 per ounce, or you could say it's 19 cents per ounce. Or if you want to do the $0.19 per ounce, you can, but for every ounce of cereal that you're getting, you're paying 19 cents. If you do the $3.99 divided by 24.5, you get a 0.16. So in other words, for the large box, you're getting 16 cents per ounce of cereal. So which one's the better deal? The large one. I want a quick comment, though, that you might have a different scenario, such as where they're measuring miles per gallon. So you'd have a number of miles over a number of gallons for two different cars. And in that case, maybe the higher number would be the answer to the question if they're saying which car has better fuel economy. So you have to look at the question to determine is the high number the answer or is the low number the answer.